So in this video, I am going to explain how to write informal results to PhysLean. So informal results are useful because they let you plan or make a blueprint of an area within the project. And this is kind of similar to the blueprints that you might see for projects like Firm/Theorem. The only difference here is that because we're following an ethos of like MathLib, where it's a broad, this project's for a broad area, it's a monolithic library for physics, there's kind of a better way to do this that's more suited for such a project than following the traditional blueprint approach that is used for some of these projects which are after a given theorem. And that way is to include the results directly in the lean files themselves. So what we currently have, obviously this infrastructure could be made better, but what we currently have and how to do this is basically what I'm gonna explain in this video. Luckily, we can do everything from the web browser here because we're writing informal results. There's nothing we need Lean for, so we can just do it all from the web browser. We don't have to download Lean or clone Lean to our own desktops. It is easier if you do that, but I'm going to show you in this video just how to do it completely from the desktop. So what you see now is the GitHub page for PhysLean. I am logged in. And the first thing we want to do is we want to make a fork of PhysLean. And what this is doing is taking this repository, which is the main repository of PhysLean, and building our own little version of it that's ours that we can work with without having to worry about messing up something on the big repository. So we're going to keep the repository name the same. We'll keep the description the same. Let me actually change this to just put test, just to make sure people don't get confused. But this is just a fork of the main repository. I'm going to create this fork. And on this fork, we will be able to edit it at will. If you also ask me and you really want permission to edit the main repository using branches, I can give you that permission, but it's probably best to stick with the fork way. So now we've got this fork, and we can see here, because I put test PhysLean, we're on this local fork. We're not on the big main branch or the big main repository. Now we're on our own personal repository. So let's say we want to add an informal result. So the first thing we want to do is we need to work out where the informal result should sit within PhysLean. And there are a bunch of different areas. So we need to home in down to the area that we are interested in. So let's say we want to do something in quantum mechanics. Let's say we want to do something which is one-dimensional, and we get to here and perhaps there isn't something, there isn't an area that suits what we want. So we can come over here and we can add, we can create a file. And we could create, for example, let's say test QM, our QM problem .lean. We want to make it a lean file, so that is what the .lean end here goes. And then this is basically a blank lean file. You could also put one of these informal results into an existing lean file. I'm kind of showing you the extra step here, which is adding these to a new lean file. So the first thing we want to do is we want to write a copyright statement at the top of our file. So I'm going to go over to some other random lean file. I'm going to copy the copyright statement and I'm going to paste that at the top. And obviously for the copyright statement, you put your name here and your name here. Luckily for me, this is my name already, so I can leave that as it is. So to use these informal results, you need to import a couple of files. So the first one you need to import is physlean.meta.informal.basic. And then the other one you need to import is physlean.meta.todo.basic. And these give you different forms of informal results that you can use to plan the subject, or plan informalization, or plan a formalization. So once we've done that, we need to write at the top of the file, we need to write a little module doctrine. So let me write something fake, an example QM problem. And then in this problem, this file, or this module rather, contains an example quantum mechanics problem. And what you would do in this doc string is basically explain what the file is, give any references. So maybe we want to give some references. So ABC in ... etc. and so on and so forth. So this modular doc string is basically the thing that somebody would read the first time they're looking at the file. It should give them an overview of the file, how it sits in the context of everything else, and what it currently contains. So if it only contains informal results, it's probably best to include that, maybe in an implementation note. So this file only contains informal results. Okay, so once we've got to that point, what we now need to do is we can start to write our informal results. So there are a number of different types of informal results you can write into PhysLean. The simplest one is a to-do item. So that's basically an item that's just a string by itself. So to write a to-do item, we write to-do. Then we write a unique tag for this. And this can be anything you want. Preferably keep it as short as possible. But it just needs to be something that is unique to that to-do item, and that helps with putting the to-do item on the website and meaning you can track its progress. So we could give it a random tag. So we could even give it like today's date and perhaps the initials and then 1 for the first to-do item I wrote today. And then that's just followed by a string, which is what happens, what you want to be done. So this file, include lemmas related, just need to move something, related to this quantum mechanical problem, in particular lemmas 5.2 to 5.3 of ... So that's kind of like, to-do items are fairly for like generic statements, more generic items, but then we also have informal definitions and informal results. Sorry, informal lemmas. So to write an informal definition and a formal lemma, the first thing we need to do is we want to write the doc string. And that doc string is going to be at the English statement of the definition. So for example, the definition, the quantum harmonic, the Hamiltonian of this problem corresponds to H equals ... So once we've written that, we then write informal def, and we give it... I'm just going to go and check the actual syntax. So if we ever forget what the syntax is, we can come over to the website and or the original, we can just search for some existing examples. Okay, so for an informal definition, we want to give it a name. So in this case, it will be test qm.hamiltonian. And that name needs to be unique, and it should be the name that you would want the formal result to be equivalent to. And then you type where, and then you give it 2 arguments. So you give it as dependencies, and the dependencies is basically a list of results that this result depends on. And this is used to track, basically connect them in a sort of graph, so you can see, what needs to be done, what needs to be formalized before this result is formalized. So in this case, perhaps there is a result in PhysLean that is called one dimension Hilbert space. And so this is the name of the result, and then you put these 2 back quotation marks, and this will give you an error in Lean. It doesn't matter that it won't give you an error here, but in Lean this will give you an error if this doesn't work. So if you end up pushing this and it doesn't work, you'd find out. But yeah, this should just be anything in this list separated by commas. This should just be anything that this result is going to depend on. And similar to how we have a tag here, we also need to give this informal definition a tag. And again, it needs to be unique to that result. So we can also do informal lemmas. So obviously informal definitions are for definitions and informal lemmas are for lemmas. And so we could do, for example, Hamiltonian is summation. Oh, sorry, I should also say that in this doc string, you need 2 dashes there. I would keep it for 1 when you start to write it and then replace it with 2 once you've written the informal definition. Again, so we need a doc string for an informal lemma. And for the doc string of the informal lemma, you probably want to split it into 2 parts. You probably want to split it into the statement. So the Hamiltonian, I spell Hamiltonian, of the test QM problem is summation. And then you probably want to give a proof of it as well. So, or an English proof of it, and that could be the proof follows from triviality. But the more explicit you make these statements of the lemma and the statements of the proof, the easier it is for somebody else to come and formalize it. And if you think the proof can be split up into smaller lemmas, or you think a definition can be split up into smaller definitions, do split them up into smaller lemmas and definitions. And again, with this informal lemma, we basically just give it the same sorts of things. So in this case, it is going to depend on this informal. It's going to depend on this informal definition here. So we can do this. And we also then need to give a unique tag. Great. So once we've done that, we can commit our change. So we go commit, and we can commit it directly to the master branch, I think. Okay, we click OK there. So that has committed our change, but this is, remember, it's our local version. So we haven't changed anything on the main GitHub repository. What we have done, as you can see here, is we've changed something. We've added something to our own local version or our own personal version of PhysLean. Now, because we've made a file in PhysLean, what we also need to do is we need to edit the PhysLean.lean file so that it imports that file we just made. So we do that by going over here, and I'm going to have to guess because I can't be bothered to look, but we made a file that was like this. Yeah, we just basically find where it sits alphabetically. I think it probably actually sits here. Sorry, you don't put the dot lean. So something like that, where this is the file name with dots that you just made, and we commit that change. Copilot helps us out a bit here. We can commit directly to master, and that's, remember, so that's saved onto our local version of PhysLean. And then when we're ready, when we think, we've made the changes and we want to contribute that to PhysLean itself, we come over here, we open a pull request. We go, for example, feature, add some informal results to quantum mechanics. And I'm going to put this as a test or an example, just so I remember to delete it later. We create this pull request. Really, you should also write a description of what the pull request is about. And then that gets pushed, that pull request is made to PhysLean. And I or somebody else will look at it to make sure that it works. There are these linters that will run on it, and they'll check that certain things are correct. If there's small things that are like, there's some simple reason it doesn't build, then either you can fix it or one of us will fix it. So for example, Here, there's some trading white spaces declared on a line. It's probably fairly easy to remove by going through back on our fork and removing those white spaces, or someone like me can obviously do that a lot quicker on a local version on our desktops. So that kind of explains how to do this. Let me go over to the PhysLean website where I want to show you the to-do list. So the to-do list is currently the only place where these to-do items appear. And you can see there are a bunch of different to-do items. So we covered these two and this to-do item. These two are slightly more complicated because they require you to download Lean and work on your desktop. But yeah, and they all appear here, and you can filter by different types. You can restrict to a given area, for example. And yeah, at some point there was a nice graph showing all of the interconnected dependencies of the informal elements and definitions. That graph is currently broken. So if you do have time and you are more interested in the computer science side of this, it'd be great if somebody could do that at some point. But yeah, hopefully that explains how to add informal definitions and informal elements to PhysLean.